Item discrimination analysis in SPSS and Excel for multiple choice question exam or exams using Point-Biserial correlation coefficient. Item discrimination. Item means a question or refers to a question. Item discrimination assesses the exam quality, assessing each question in exam sheet as either good or bad question. It does differentiate between students who have mastered the subject content from those who have not. It does determine how well an item is discriminating between good and poor students. Point-Biserial correlation coefficient assists the educator or educators to identify good or bad test questions. So the coefficient is one of the item discrimination index. It does measure the discriminating power of an item or a question. It is a method of measuring the relationship between student total exam scores, continuous variable from 0 to 100, and students' item mark or score, dichotomous variable. Dichotomous mean two categories, correct or wrong answer. It does measure the strength of the relationship between two sets of data. So here in this case we have two variables. We need to correlate two variables with each other. One of the variables is continuous, such as the total mark, which is in percentage from 0 to 100, and the other variable is categorical. Two categories, correct or wrong answer. The test, statistical test, the Point-Biserial correlation coefficient, does measure the direction of the relationship, and it does calculate the significance of the relationship by producing a p-value. A p-value less than 0.05 indicates significant relationship. P-value greater than 0.05 indicates non-significant association. Now, the statistical test for Point-Biserial correlation coefficient generates a value or values, and these values range from -1 to +1. +1 indicate a perfect correlation, positive correlation. A -1 indicate a negative correlation, a strong one. Now, positive value of the coefficient indicates that the learner who answered a given question correctly also have a high score on the overall exam, and those who answered the same questions wrongly have low total mark in the test. A high positive value indicates that the question is discriminating high performing students from low performing students. Negative coefficient value means a high performing students are getting the answer wrong and low performing students are getting it right. In this case, remove the question from the exam paper. However, if the coefficient value is 0, that means the item or the question is not discriminating between students. So it's worth changing it or modifying it. In this small table, any value of point-biserial that is greater than 0.4 indicate that the question is very good, and a value of 0.25 to 0.4 suggests a good items. Fair item have a point-biserial value of 0.15 to 0.25. Any question that have a value of point-biserial of less than 0.15, then it is a bad question or a bad item that worth modifying or omitting from the exam. Here in this table shown an exam result for 15 students answering 15 questions and multiple choice questions, and each question is recorded, the score for it, as either 0 on 1, 1 is correct answer, 0 wrong answer. To perform biserial correlation coefficient statistical test to perform the statistical test to generate the coefficient or calculate the coefficient, we first have to calculate the correct answer that each individual student has achieved, and then by adding all the questions scores for each individual student together, divide them by the total number of questions, in this case 15, and then multiply them by 100 to generate the total mark or total score or the percentage of the total mark as it is given here in the blue marked values in the column labeled as mark. So for in the point-biserial correlation, once the total mark is calculated, the test is performed, and the test will correlate each specific questions, the value in each questions, the scores in each questions with the total mark, as shown here in this again slide. To calculate the R, which is the coefficient, or to execute the point-biserial correlation statistical test to generate the coefficient, take every question with its value and scores 0, 1, and correlate that with the total mark for the whole students. And we do this for every question or every item to generate specific R value for each question and a P value for that question. This is how it is done in a statistical package or software. In this slide, this is a scatter plot showing a correlation between wrong and correct item, an answer wrong and correct for question number 5, and as we can see here in the y-axis is labeled as exam mark from 0 to 100, and on the x-axis it is labeled from 0, 1. 0 means wrong answer, 1 means correct answer. As we can see here, most of the students that who answered question number 5, item number 5, tend to have higher overall exam mark compared to those who had answered the question number 5 wrongly, tend to have lower total score or total mark. So this question 5 from this scatter plot can be considered as really a good questions. It can discriminate between the high performing student and low performing students. The next slide shows item analysis using the point-biserial correlation coefficient either in SPSS or in another package software called Excel. As we can see here, for each individual question, there is a value calculated for point-biserial value calculated and a p-value for question number 1 to question number 15. Again, here we have questions with their point-biserial value and p-value. In the red labeled scores, question number 1, we see that the value is negative and it is not significant because the p-value is greater than 0.05. Again, this question number 1 indicate that higher performing students are answering this question wrongly and low performing students are answering it correctly. So this question is a very bad question that need to be removed from the exam as it is negative. If we look at the question number 6, which is labeled yellow, we can see the value for the coefficient or the R is close to 0 and the p-value is very high. So this question is not discriminating between high and low student. So it is close to 0 and it's considered to be a bad question and it's either required to be modified or omitted from the exam. If we look at question number 11, 12 and 13, we can see that the R value is very high, 0.51 for question number 11, and the p-value is less than 0.05. So this question number 11 is a very good question in discriminating between students. So it is classed as or categorized as a very good question. Again, number Q12 also a good question as it is the value for it 0.33 and the p-value less than 0.041. And the same thing for question number 13. It is, we can call it a very good question as the value, R value is 0.48 and the p-value is very low. If we again go back again and look at question 2, we can see that question 2, the R value is 0.15, which is, we can call it a fair question. However, since the p-value is not significant, then this question also is not discriminating between high and low performing students and need to be remodified. Again, from this table on the bottom, we can say that question number 3 is a good question. Question number 4 is a very good question. Number 5 is a very good, if not excellent question. Number 7 is not a good question. Number 8 is a good question. Number 10 is a good question, and 11, 12, 13 I have described them. Number 14 is a very good question. Number 15 is a very good question, and number 16 I have the data for it, but it wasn't included in the tables. But again, number 16 here, it is a very good question as the p-value is less than 0.05. So this is the way to use the power of the point-biserial correlation coefficient to determine the R value and the p-value, and to look at the correlation between specific question and correlating it to the overall mark to determine whether the question is good or bad. Evaluating exam multiple choice questions and sorting them as either good or bad questions when designing an exam paper or sheet for students, and assessing those questions using the item discrimination analysis in first SPSS and then in Excel using the Point-Biserial correlation coefficient. Good or bad MCQ questions. Whether you are an educator, a teacher at school, or a lecturer at college, or a professor at university, and you are frequently involved and participate in exam questions design, and you repeatedly design multiple choice question exam paper, and you want to look at the questions and determine which one of these questions are bad and which are good, which of these questions discriminate between the student of high performing student and low performing student. The way to do that is to use item discrimination analysis or question discrimination or discriminating analysis in SPSS based on using a Point-Biserial correlation coefficient. A Point-Biserial correlation coefficient is a statistical test that is used to find the relationship between two variables or two sets of data. And I'm not going to describe the background and the criteria and the conditions in which to use the Point-Biserial correlation coefficient in it, as I've already described it in a separate video, and I have uploaded that on my YouTube channel, and I'm going to leave the link for the video in the comment box, so feel free to have a look at it. But here I will just show you how to do the statistical test and how can you tell and determine and identify a good question or a bad question. Here in SPSS I have a data for an exam question for 38 students answering 76 questions, multiple choice questions. So we have here 76 variables, 76 columns, or 76 items. These questions can be called items also. And the score or the value for each question for each individual student answered is recorded as either 0 or 1. 0 stands for wrong answer. The student has or had answered the question wrongly, and 1, the student had answered the question correctly. And to determine which of those questions are good and which are bad, we need to do a statistical test called Point-Biserial. But we need first of all to do 2 steps. The first step, we need to calculate the overall total mark for each participant or each student achieved. So we need to generate a column here for the total overall exam mark or total exam score for each individual student. So we are going to generate a column here for that, and we are going to calculate that in percentage. So we're going to add all the scores or the value for each of those 76 questions for each individual student, add them together, divide them by 76, and then multiply them by 100. The way to do that is to click in SPSS, to click on transform compute variable. Again, there are 3 ways to calculate the total exam score or the overall exam mark. First one is you click on bracket, drag the first variable, click on plus, second variable plus, and then plus, and so on until you move all the questions in between the bracket from question number 1 to 76, and then divide that by 76 as we are adding them up, and then dividing them by 76, and then multiply them by 100. So this is one of the way to calculate the total exam score. The other way is to click on function group all, then scroll down to statistical, and then from statistical choose the sum command and drag it to the numeric expression. Again, you have the sum command and then a bracket, and we need to move the first variable separated by comma, second variable separated by comma, third variable separated by comma, and so on until you enter the 76 variables in between the bracket. Then you need to divide that by 76, multiply that by 100. So this is the second way. The third way, which I am going to use here, is to use the mean function. Again, so we need to generate a target variable. We're going to call that target variable over all marks. Overall marks, and again we're going to move all the scores, all the variables, all the items, and with their score in them into the bracket one by one, separated by comma to generate the mean. So we have here 76 items or variable, and I had already typed this in Microsoft Office, and I'm going to copy it from here, right click and then copy, and then paste it into the in between the brackets, so to save me time. So they are there to use whenever I need them. So here we have the mean, and in between the bracket the variables or the items from question number 1 to question number 6. And to calculate the overall mark, i.e. the percentage, I need to multiply this by 100, as of already here the average has been calculated. And if we click on OK, a new column is generated, or a new variable is generated, which has the overall mark or the percentage of each student achieved in the exam. So here now we have 76 variables and an overall exam marks. So, and we want to identify and determine which questions are good and which question is bad using the Point-Biserial correlation. So the next step is to do a Point-Biserial correlation coefficient. Here, as we can see, we have these questions, and we want to find the relationship or the association between question number 1 with the score in it and correlating that with the overall mark. So to determine whether this question is good or bad, whether it is discriminative or not. And we need to do this for all the 76 questions together simultaneously. So each one by one, comparing each questions with the total mark. So we have here 2 variables. The first variable is the item or the questions, which is categorical because it only had a score in it 0 or 1, category 0 and 1, right or wrong, 0 wrong, 1 is right, and the continuous variable, which is the percentage. So here we can use the point-biserial correlation coefficient. And the way to do that is to click on Analyze, scroll down to Correlate, then to bivariate, because we are all looking at here bi mean two, variate mean variable, two variables, and I'm going to reset this. Again, we have here the 76 questions or items, and we want to correlate each one individual one with the overall mark to calculate the point-biserial value or coefficient. Click on Control A to select all the questions with the continuous variable and drag it into the variables. And we're not going to change anything here, keep it as it is, but we make sure that we use here the Pearson correlation coefficient test, as the point-biserial correlation coefficient test is based on the point-biserial is based on the Pearson correlation coefficient. If you click on OK, an SPSS will generate a correlation matrix for question number 1 to question number 76, correlating this intercorrelation between each items and correlating them with the overall marks. So we are interested in this column here, or sorry, in this row here at the bottom, and on the final column, which is titled as, labeled as overall mark. And again, if we look at the final row here, which says that overall marks, Pearson correlation, and then it's given a Pearson correlation value and significance of that value. Again, for which is again Pearson correlation represent point-biserial. For point-biserial correlation, the value is from -1 to 1 to +1. -1 indicates it's a negative relationship, and +1 it means a positive relationship. And the higher the value, the stronger the relationship. Again, and for purpose of analysis of this test, for the point-biserial correlation, we set the value that anything below 0.15 value for point-biserial, the question or the item is poorly designed, or a poor question, or a bad question. Anything above 0.25 is a good question, and anything higher, it is a very good question. However, simultaneously, we need also to look at the statistical significance. Anything below any value for p-value for the test below than 0.05, then it is statistically significant and the correlation value is significant. In the first example here, we can see that the correlation between question number 1 and overall mark is 0.22. That's considered to be fair question. However, it failed to be statistically significant, so we will consider that questions probably considered to be a bad question. Again, the same thing for question number 2. The p-value is 0.36, so it is less than 0.05. Again, this question is not statistically, the value for it is not statistically significant, so this question is also a bad question. However, for question number 3, the p-value is 0.029, which is less than 0.05, so it is statistically significant, and the correlation coefficient is 0.35. This is a really a good question that can discriminate between students. Again, a fourth question is 0.5. This is a very good value or coefficient and the statistically significant. The fifth question is 0.7. The value for the coefficient is 0.76, and this is really a very high value. So this is really a very, very good question. And the sixth question here, as we can see, the point-biserial correlation coefficient is very close to 0, so it's 0.054. Anything that is close to 0 or 0 is indicate that the question is not discriminating between students. So it is not a good question, so it is a bad question. Meanwhile, also the value for the statistical significance is greater than 0.05. So this question is really a bad question, and so on and so on and so on. So this is the way to determine which question is good and which question is bad. And if I want to save or export this table, which I'm going to do, and I'm going to export the data, the table or the outcome for the statistical analysis for the point-biserial into either Excel file or Word documents or PowerPoint or even as a PDF. And I'm going to export this table here, the correlation matrix, as a Excel file. And the way to do that, click on the table and then right click on export, and then another window will pop up, and I'm going to select Excel 2007 and higher, and I'm going to call it again point-biserial, saving it, and I'm going to keep the tick for open the containing folders once the file is exported. If I click on OK, it says that it already exists, so I'm going to overwrite it. So the file is exported into the Excel in a format of an Excel file which have the correlation matrix in it, and in this occasion I am only interested in this row. So what I'm going to do is I am going to select the rest and delete it. But I'm going to need, I'm going to keep the question number 1, but I'm going to questions or items, and I'm going to delete the rest. So I'm just only interested in the correlation between the questions and the total marks. Let's make sure that I have everything here set up correctly. So if I right click, select, and then right click and delete, and then click on OK, I will have here the correlation between questions and the value of the correlation and the significance. So I'm going to get rid of the first column and get rid of the last column as it is the number only, and I'm going to rename this, instead of Pearson correlation, point-biserial, as it is based on Pearson correlation. So I have here the point-biserial for every individual questions in your exam paper, and I'm going to get rid of this column as there is no need for it. So we have the p-value and the value for the coefficient. So anything with statistical significance and a higher value indicate that the question is good, and anything below it is bad. Here there is an interesting observation. I need to mention it. In one of the data here, let me look for it, minus. There is a minus point-biserial. minus indicate that high performing students are answering the question wrongly, and low performing students are answering it correctly. So in this case, there is something wrong with the question, and it's the best way is to remove the question and replace it by another question. So this is one of the benefits of doing discrimination analysis, item discrimination, using the point-biserial correlation coefficient, as it will highlight the question, which question has problem in it, or which question is bad and which question is good. Again, I could also take this data here, copy all the 3 columns or just the 2 columns here. I'm not interested in the first. Copy, and then I had this data in a Excel file. I could also here I have it here somewhere in exam question. I could add it to the data I had already for this exam result, and I could add the Pearson correlation here at the end of the either in columns or in row, and I do prefer it in row here. Again, as for every question biserial correlation, this is question number 1, and this is the point-biserial value, and this is the significant value or the p-value for the question. So in this way, I had shown you how to determine which question is good and which question is bad based on item discrimination and analysis using the point-biserial correlation coefficient. Assessing the quality of multiple choice questions in an exam sheet by evaluating the ability of the MCQ or a question, its ability to discriminate between a high performing student and low performing student, i.e. measuring the power of each individual questions in its ability to differentiate between good students and high quality students and low performing students, based on evaluating each specific questions, whether it is a good questions or a very poor questions that probably require replacing or removing. The way to do that is to use an item discrimination analysis in Excel based on point-biserial correlation coefficient. Again, this assessment of the questions is of a great benefit for those who are involved in education and designing exam sheets or paper, and to want to make sure that the questions serve the objective of their subject or taught modules in a way that it will fulfill the requirement for and it assess the learning objective of a module. So doing an item discrimination analysis is an important step in assessing exam questions, multiple choice questions. I have generated, as I said before, a video clip describing what is point-biserial correlation coefficient and the background for it. For those who are interested, feel free to look at the video in my YouTube channel. Here in Excel, I have entered a data from an exam result for 38 students answering 76 multiple choice questions from question number 1, Q1 to Q76, and each individual or each student answered the questions, the data recorded or entered as either 0 or 1. 0 stands for wrong answer and 1 indicates correct answer. So each question has a value or a score of either a 0 or a 1 answered by each individual student. 1 for correct answer, 0 for wrong answer. So here in these questions we have only two types of scores, 0 or 1, which will indicate that it is a categorical data, so just 0, 1, 0, 1. And if we want to evaluate each questions and look at the quality of each multiple choice questions of those 76 questions, and the first step to do that is first of all to calculate the overall exam score for each individual student, or the total score that each individual participant had achieved in the exam. And the way to do that is to scroll here to the far right, and I'm going to generate a new column, and I'm going to call it total score. And the way to calculate the total score is to add up all the value or the scores for each individual participant has achieved for all the questions, 76 questions. Add them up, the value for them, and then divide them by 76, and then multiply them by 100 to calculate the percentage of the correct answer or the total score, which we are going to use these scores in subsequent analysis. And the way to calculate that is if we just click on the cell here and then click on the symbol here indicate, we can use two methods here, either using the sum, adding up all the value, or use the average. And I'm going to use the sum method, in which I'm going to select the question number 1 to question number 76 as it's showing here, equal sign sum P2 to PY2, and I'm going to divide that by 76, since we have 76 questions, and then multiply that by 100. So the total score, or the total or the percentage of the mark for each individual student for the exam, first one is 82. And if I select and drag the cell toward the end, it will autofill the total score for each individual participant or student. So here we have 76 questions scored as either 0 or 1, and a total score of 38 students, and the scores in a percentage. So here we have a categorical data for each one of these questions, 0 or 1, and a continuous data percentage from 0 to 100. And to determine which one of these questions is discriminative between students or not, you need to do a point-biserial correlation coefficient. And point-biserial correlation coefficient is based on Pearson correlation coefficient. And to do the analysis, we need two sets of data. The first set is dichotomous or categorical, as we have here the questions, and the second one is the continuous. So we need continuous, which is the total score. So we need to correlate and find the relationship between each individual question with the total score. So we need to study the relationship, calculate the relationship through a statistical test of Point-Biserial between each individual question and total score, and to generate a value for the correlation, and this value indicates the strength of the relationship. And the way to do that in Excel is if we click on data and then click on the data analysis. Either way, if you don't see the data analysis icon on your Excel sheet, the way to bring it on is click on more and then go for options and then scroll down to add in, and then scroll down here to manage add in and click on this analysis toolbar, which will make the icon appear here. So if we click on the data analysis, and then I'm going to, here we have a list of tools or tests to use, and we're going to select correlation since we are looking at correlation, and this will use the Pearson correlation coefficient. If we click on OK, another window appears, and we are going to input the range. So we are going to correlate the data, the total score, with all the 76 questions. Then we need to click on this arrow, and I'm going to click here, then scroll to the beginning of the up to Q1, and then hold the shift key and click on Q1. Again, the data that we need to include is highlighted, and then click again on shift control and on the below arrow. This will select all your data that you want to correlate the total score with all the questions. And if we need to keep this label in the first row ticked in, and we're going to generate the correlation in a new worksheet. If we click on OK, again a correlation matrix is generated, as we can see here, in which each question, so you look at the bottom one here, each question is correlated with the total score. Total score correlated with the question 1 up to question 76. So now here I'm going to rearrange and delete the data that I don't want. So I'm going to get rid from this row up to 76. So by holding the shift key, click, and then right click on it, I'm going to select delete. Again, this will delete the other data that we are not interested in. So here what we have is the correlation between question number 1 and total score or overall mark, and question 2, 3, 4, and so on. And to rearrange the data in a much better way, we highlight this row, then right click on format the cell, and I'm going to click on number, and I'm going to use only 3 decimals to make the value here easy to compare. So here from this data we can see that we have the correlation coefficient for all the 76 questions, and each question has a value. I'm going to get rid of the last one because it's correlating total score with total score will be 1. So to delete this one. So now we have the value, the coefficient value, the Point-Biserial coefficient value for all 76 questions. And in fact, I want just to color code those value so that will be much easier to look at the data. So if I highlight the row for total score and then click on home and then click on conditional formatting, then click on new row, and in the new row I'm going to use a 3 color scale, and I'm going to change the type into number for all, the minimum, the midpoint, and the maximum. And I'm going to enter here as a -1, since the range for the point-biserial coefficient is from -1 to 1. So, and I'm going to keep the midpoint 0. The maximum 1 is here is 1. And I'm going to change the color. For the minus, we need to make it red. For 0, which is, I don't want to make it white, as it is indicate no correlation. And for the maximum 1, put the color coded with a green. If I click on OK, and here again color coded, all these cells are color coded again according to the value within it. As we can see here, that the higher the value, the more greenish the cell will be. As here the correlation coefficient is 0.76, and here is a poor correlation of 0.15, and here also a 0.05, and also interesting really toward a pinkish, toward reddish color, which is indicate a minus correlation, and here also a minus correlation. Now what does this value mean? This value mean that if you have a value of P, I'm going to call this point-biserial, as this is the point-biserial now, and then I'm going to make it a little bit darker. So what does this value mean? Indicate that the higher, the closer the value to 1, the stronger the correlationship between each questions and the total mark. So in this case, anything above 0.15 is a fairly good question, or anything from over 0.25, it's a good question, and anything over 0.4, it is a very good question. Any value close to 0, as here, it indicates that there is no correlation between the question and the overall score, i.e. this question is not discriminative. It doesn't discriminate between high performing and low performing students. So this question needs addressing either by remodifying it, rewriting it, or excluding it and removing it from the exam sheet. A negative value here indicates a problem, as it is minus 0.294. This indicates that high performing students answered this question wrongly, and low performing students answered the questions correctly, which doesn't make sense. So there is something wrong with these questions, and the best way for it is to exclude that question and remove it from the exam. And also similar things to this, also question number 70, as it's also negative. So negative mean it is a bad question. So it's to get rid of this, anything close to 0 or minus need to be removed, and as it doesn't discriminate between individual. So this is the way to discriminate between questions and find out which questions are good and which questions are bad, which questions to keep and to use in the future exam sheet, and which one to replace or rearrange or rewrite. Now, this value here for the point-biserial, although it is, some of these values are high, but again this value has to be statistically significant, has to be confirmed by calculating the p-value. So p-value for each correlation between questions and overall score is need to calculate the p-value, as the p-value is the determinant factor in the significance of the relationship between the questions and the overall score. So to calculate the p-value for each individual questions, correlation of each individual question to total score, is to click on, if we go here again to this data, and we want to calculate the p-value, I'm going to select some. Unfortunately in Excel we only can do it one by one questions by one, so we need to calculate the p-value for question 1 and then question 2 and then up to 70, question number 76. So I'm going to select question number 5 here and do calculate the p-value for question number 5, as the p-value here for question number 5 is 0.76, which is very high, but is it significant? And the way to find out the significance is to calculate the p-value. To calculate the p-value for number 5 here, you need to click on the data, then icon for data analysis, then scroll down here on the list and use the regression. We are going to use the regression to calculate the correlation between these two variables to get a p-value. So if you click at OK, and in this window we are going to enter a data for y-axis input. In case it is a correlation, it is a regression, then you have y-axis and x-axis, and it's a correlation between them, and then calculating the p-value. For y-axis we are going to use the score data here as it is selected, total score, as this is the overall mark. And for the input, again we're going to select that, we haven't selected that. If I click on this here and then hold the shift control and down arrow, it will select just only the data and the label for that column. And we'll do the same thing for input. For the input X range, I'm going to use calculate the p-value for question number 5. So I want to scroll to number 5, click on it, and then hold the control shift and then arrow indicating to the lower arrow, and then click on here again as you can see that number 5, let's do it again, double check. So if we go for number 5 here, click shift and then black arrow is selected here, as we have seen here, 5 and arrow column 5 is selected, and then click on label, and we are going to generate the output in a new worksheet. If we click on OK, here a few tables are generated. What is important here in this tables is we need to look at just only the question number 5 here. I'm going to highlight that with the yellow color, and of all this, what is interesting to us is the p-value. This p-value, as it is, again this video look like a little bit complicated, so we need to change the format of the cell to a much easier decimal point, change it to 3 decimal point. Again, as we can see, this is the p-value correlating question number 5 with the overall mark, and the p-value for it is 0.00. So question number 5 here, if we go back again to the MCQs, question number 5, and here in this sheet, question number 5 has a p-value which is equal 0.000. So again, we need to set up this for the format of the cell into 3 decimals, so we need to see the decimal. Click on OK. I see the decimal. So this question number 5 is really an excellent question. First of all, it has a high value for the correlation coefficient, 0.76, away from 0 toward 1, and a statistically significant p-value, which is 0.000. And for the p-value, for anything to be statistically significant, the p-value has to be less than 0.05. This is the cutting point. Anything less than that, then the value we are looking at is significant. So it is significant or important value. Anything below 0.05, this is significant. Then this value of 0.76 is a significant value, which means that this question number 5, is a very good questions, a very excellent questions to keep for discriminating between students. I will also look for another example here, and I'm going to look at question number 6. As we can see here, the correlation value is 0.05, which is close to 0, which might indicate that this question is a bad question. Again, we need to calculate the p-value for it, as without p-value we cannot really make a conclusion on the quality of these questions, as the value for Point-Biserial by itself is not enough to judge without the p-value. So we need to find out the p-value, and to find out the p-value, again we go to the MCQ, the sheet, original sheet, or data. It has data in it, and then data analysis, and then regression again. And we are going to use keep y axis or input y range as the total score, and the x range we're going to select number 6. If I select, then Control Shift and below arrow, and then click on here, click on label, keep it as it is, and click on OK. Again, another regression tables is generated. We have to do again the same changes. Change this into, format the cells, change it into 3 decimal points. The p-value is 0.79. If we copy this and we go here to this 0.7 and place it here, 0.749. Again, if we look at the p-value for here it's very high. It is above 0.05. So once we see this value here, so we have to reject this value, this reading or this value from correlation coefficient, and we say that this questions is poor questions, and we should not consider this questions in the exam, as the correlation is very low, and at the same time it is non-significant. Now, one last point before finishing, I want to pick up a negative question. I'm going to do the same thing for negative question. Here for question number 47, we have a correlation coefficient minus, which indicate that the question is not discriminating, as in this question high performing student answer this question wrong, and low performing students answer it correctly. So we need to find out whether this question is worth considering. Again, if it is minus, then it does not worth considering, and it's worth removing it. It is important to remove this question as it's not discriminative. But again, we had to determine the p-value for this correlation value, which is minus 0.294. And the way to do that again is to go to the MCQs, and then data, click on data analysis, regression again, changing that into selecting now the data number or question number 47. Click, Control Shift, below arrow, and then click on OK. Again, another table is generated here, and as we can see here, the value, again changing these things into formatting the cell, so making it 3 decimal points, copy MCQs, and going to our first sheet here, and we're going to place the value here. Again, this is the p-value for this test when we correlate question number 47 with overall scores. It gave us a minus 0.29 value and a p-value of 0.07. Again, this value is greater than 0.05. So in this case, we discard these questions as it is the correlation is not significant, and it is essential to remove this question from the exam. And again, you have to do these steps one by one for all the rest of the questions. You need both the value for the coefficient and the p-value to make your judgment on the question. So this is the way to do the analysis item called item discrimination or question discrimination analysis, to discriminate analysis that will discriminate between high performing and low performing based on the questions, evaluating the questions using a point-Biserial correlation coefficient value with a p-value for it, statistical significant value for it. So this is the way to judge whether a multiple choice question is a good or bad question, and this can be of a tremendous benefit to those who are involved in education and assessment and designing exams that is of a high quality and high standard one.